So for the practice problems, for the first question, determine the oxidation number of each element in the following compounds. We have 6 different compounds here, and we've split it up into its elemental form. And then we should always remember that oxygen prefers a oxidation state of -2. Unless it's a O2 gas, then the oxidation state will be 0. So for SnCl4, chlorine being a halogen, it will prefer to be -1, and there's 4 of them, so chlorine would be -1, so that means Sn would be +4, as the charge is 0 for this compound. O2, as I stated previously, will prefer a charge of 0. H3O plus, O2 prefers a charge of -2. So we know that hydrogen prefers a charge of +1. There's 3 hydrogens, making it +3 minus the 2 from, or plus the -2 from oxygen, what gives it the +1 charge. We have S2O3, -2, so the whole compound has a charge of -2. We know that oxygen prefers -2, so times 3 would be -6, and that means sulfur would have a charge, each sulfur would have a charge of +2, giving the full compound a charge of -2. KMnO4, oxygen would have a total oxidation state of -8, K +1, and then manganese would have +7 to have a compound charge of 0. Ammonium sulfate, separated into each compound, would have ammonium is usually +1, but if you separate it, there's 4 hydrogens, so +4, and then nitrogen would have to be -3 to get the +1 charge in ammonium, and then sulfate is oxygen is -2, and sulfur is +6, as 4 oxygens equal -8, and then +6 is total would be -2. And then determine the oxidation number of carbon for each compound. So then here we have hydrogen, so +4, which means carbon would have to be -4. Here oxygen's -2, +2 from hydrogen, so carbon has to be 0. Oxygen equals -2. Carbon has to equal +2 to get the no charge on the compounds. And then oxygen would be an oxidation state of -2 times 2 would be -4. Carbon would be +4.